All right, so moving on from the frequency table and everything, we're going to be looking at conditional probability, which is just like probability, except we're going to put some kind of stipulations and kind of narrowing down the focus a little bit when we do these probabilities. So we're not saying, okay, of the whole population, what about just people that like the movie Die Hard, or people that like the movie Shakespeare in Love? That's okay. So we're going to be breaking it down into groups and then find the probability of it. And that's what conditional probability is. So the probability of an event occurring with some sort of limits on the population. So not anybody, again, those that like Die Hard, or those that like Shakespeare in Love, or, again, those that like both. How it would be written is like this. It's P of B, and then with that line A. And how you would say it would be the probability of B given the events of A. So because of A, which is the one that limits the population, how often will B occur? And so to find this probability, you have to find the probability of A and B occurring, both of them at the same time, okay? And then divide that by the probability of just A occurring, or by the number of times A occurs, okay? So if we look at this, if we want to look at this, we would say, okay, what is the probability of someone doing chores last night that was male? So we're assuming that they are male, and we want to go, okay, what's the probability of it occurring that they are male and they did chores? So what you would do is you'd go, okay, well, the probability of did chores and as male, so what's the probability that they did chores and they are male? So both. Well, you look up here, okay, male and did chores, yes, that would be 7. So it'd be 7 over the total number. So it'd be 15 plus 20, or 15 plus 13, 28. So 7 over 28. Okay. Now you would divide that by the probability that it's male. Well, how many males do we have? We have 15 males out of 28. Okay. 15 out of 28. And so as you see here, if you were to simplify this, flip, multiply this, you'll get 7 over 15. Okay. 7 over 15, which is the probability of it occurring. Okay. All right, so now the next thing is by using something called a tree diagram. And a tree diagram is just a way of writing everything out so that you're able to find what you're looking for. So what you'll do is you'll start with a single point, and you'll go, okay, break it up. Either it's going to be male on top, or it's going to be female on the bottom. Now, what's the probability that it's going to be male? Well, it's 7 over 15, based on the information that's given. Female, 7 over 15, based on the information given. Not 7 over 15, it'd be 15 over 28, and 13 over 28. So 15 over 28, and 13 over 28. Okay, and that's based on the total number of males, which is 15, total number of females, which is 7. Okay. After that, you're going to go look at the male. Okay, male. Yes, they did chores. No, they did not do chores. So what's the probability that out of the males, so just out of 15, so it's just going to be something over 15, something over 15. How many said yes? 7. How many said no? 8. And then for females, you do the same thing. Yes, no. Okay. What's the probability for them? It's not going to be over 15, it's going to be over 13 because there's only 13 females. So yes, there was 7 out of 13. No, there was 6 out of 13. And now to find the probability of any of these, so if you want to go female and no to chores, okay. So female and no to chores, what you'll do is you'll take you will take them and multiply them together. Yes, you would take them and multiply them together. So you'd go 13 over 28 times no would be 6 over 13. 6 over 13. And that would be your probability of it being female and no from the beginning. All right, so let's say we have this situation. So in Portland, so it's one of these Portlands across the country. You know, all the blue states has a Portland. So, you know, it could be Texas, or it could be New York, or it could be Connecticut, or Wisconsin, North Dakota, Oregon, Maine, you know, one of those. So that's just, you know, I picked a city that's in a lot of different states. Now, in Portland, when it snows, only 2% of the time it's heavy. Okay, so it's a lot of snow. And when it snows heavy, schools close 95% of the time. When it snows light, schools only close 7% of the time. We want to know what's the probability that when it snows lightly that the schools are closed. Okay. So what we're going to do is that we're going to make our tree. So heavy, light. The probability that it's going to be heavy whenever it does snow is only 2%, so 0.02. Okay, the probability that it's light would be the leftover, which would be 0.98. Okay. Now after that, we go, okay, schools closed, open, closed. Schools are open, or schools are closed 95% of the time, which means that they're open 5% of the time. Okay. When it snows heavy. When it snows light, schools are open looks like 93% of the time, and closed the 7%. Okay. Now, if we want to know what's the probability that it snows light and schools are closed, what you're going to do is you're going to take the light percentage, (98), and multiply it by the probability that it's closed when it's light, which would be 0.07. So you multiply those together and you get about 6.86%, approximately, of course. Okay. So that's kind of the tree diagram. It's just another way of doing this. Otherwise, you just multiply the percentages together. Okay. So your IRAT. So here is the box. The side here is diploma, and here is experience. Okay. So what you have to do based off this box, you want to find the probability that people have a diploma. So out of all these people that are looking for a job, have a diploma, has a diploma and experience, has experience and with a diploma, and then no diploma and has experience. So these are your conditional. Okay, so these are the ones that you're going to have to shrink. This is just taken out of the total population. These you're going to have to shrink because you have your conditions here, which are the second halves of them. Okay, so find the probability of each of these.